Now, before we can actually have IP running on the router, we have to make sure that we have identified IP addresses for our various routers to use at different interfaces. And you have to put that interface IP address specifically on the interface with the appropriate subnet mask. So in this case, I use an address of 172.16.30.1 with a 24-bit subnet mask, 3 255s of 8 bits each. So I have added an IP address. Now this router has had IP enabled on it. It now has the capability of being able to use the IP protocol. Now once I've added my IP address, the other thing, it's kind of funny here, is that I actually have to bring the interface up. Remember back when we first talked about iOS, looking at commands? I was saying that commands in the positive are always the actual commands to make it a negative command. All you have to do is enter the word no. Well, in this case, all interfaces by default are down. They are shut down by default. So what I have to do is I have to execute on an interface that is not yet being brought up the no shutdown command. What this does is basically say, well, bring the interface up. Now what it wants to do is it wants to make a connection. And if you bring the interface up, you're going to notice two very, very important messages. The first message is the actual link up down, and this is a COM either up or down. You get very much the same message either time, but link up down indicating that the interface Ethernet 0 has changed its state to up. Now this first message indicates physical layer or layer 1 connectivity. I have electricity, terminating electricity, on the other end, which means I am actually plugged into something and it is indicating that layer 1 has successfully come up. The second message that I get is the line protocol. The line protocol is actually the encapsulation. Now that word should be familiar to you because that means the framing itself. In this case, the line protocol on interface Ethernet 0 is changed up, indicating that whoever is on the other end is communicating using the same frame type, and that's a bonus. Well, these two messages are incredibly important to you because what they give you is built-in troubleshooting. If my link comes up in this case, the first message, but the line protocol does not, that indicates that I have physical layer connectivity, but I do not have the same frame type. As soon as my line protocol was to come up, that means I am communicating with the same frame type on the other end. Now Cisco routers actually use messages to identify their frame type, which are keep alive. These keep alive messages get sent back and forth between routers to verify that our encapsulation type is the same and that the link is good. Actually doing, kind of a link test. Well, if ever the keep alive cannot be read by the other end, it does not receive a response, the line protocol will go down and stay down and set the frame type as corrupt. So this is great troubleshooting experience for your interfaces. Let's go to the lab real quick and take a look at this interface configuration and show you how a link and an encapsulation can change the way that an interface responds.